Peels. This is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. So, what do we have for you today? Well, today we've got Spee3D, the Australian cold spray 3D printing company, is working together with the UK military. The UK Ministry of Defence has asked Spee3D, an Australian firm, to participate in the US Army Future Command's Project Convergence in 2022. This Project Convergence is kind of like it's like a kind of ongoing project with a bunch of different events. But think about it as like a giant military jamboree with all the researchers, commercial vendors, and warfighters all together trying to look at future technologies. So they are US military people and researchers, but also UK and Australian ones. And they're evaluating over 300 different technologies. And there's an event right now ongoing that is a part of this, and it's also kind of like there's a long drawn out process that allows you to bid on contracts and to work with the military. And the idea generally is for the military to look at things like machine learning and additive and just sustainment generally, and look at new technologies and communications and everything really that's going on, and try to see what's applicable for them, so that the future developments of different parts of the U.S. Army and different parts of these international armies, in the case of the UK and Australia, can be kind of coordinated in a way. So, this is great for Spee3D. To give you an idea, Australia's GDP is less than what the United States spends on the military every year. It's 1.5 trillion instead of nearly 1.2, or nearly 2 trillion. So this is a huge opportunity for the Australian firm. Now, also specifically for Spee3D, they seem to have really focused on this military sustainment deployment type of a thing. They've got a technology that is allowed for them to spray, several hundred grams or even more than that, in a very, very sustained way, in a very, very quick way, using a rather low-cost powder feedstock, which means that this is a system that you can operate in a kind of austere environment and can make parts quite quickly, quite cheaply, compared to, like, for example, powder bed fusion and binder jet and other technologies. So it's fairly straightforward. It's all in one machine. They've got a new version of this machine that's actually a containerized version of the Spee3D printer. They've worked with the Australian Army, as you see in the picture here. They've worked with the UK military. So Spee really seems to want to be able to focus on this industry as being a sweet spot for its technology. Now, there's also something else going on here that I've kind of noticed. We're seeing a lot more things going on, and it happened initially with aircraft carriers and submarines. We're seeing a lot more going on between Australia, the UK, and the US specifically. So there's this NATO allies of groups. There was also this Five Eyes kind of groups, which are like these really close intelligence cooperating countries, which is like essentially the UK, the US, Australia, Canada, and New Zealand. But now it seems like on submarine warfare, on hypersonics, and on additive, the US has made an even smaller group, like the Three Noses or something, that all point in the same direction. This consists of the English-speaking countries of the UK and Australia and itself. So is this substance? Is this a coincidence that we're seeing a lot more events in hypersonics, a lot more work and a lot more things going on? Now, if this is the case, this could be a huge boon for especially Australian 3D printing companies, because there aren't that many. We've got Speed, we've got Tectonic. That's just about it, right? There's not a lot of vendors as well. So for hypersonics and military, the demand on the US side is so big that it could be a huge boon for these businesses to get involved in this. And it could be also a boon for companies like Wayland Additive and other kind of UK companies, given the fact that there's not a lot of OEMs from the UK besides Renishaw and Wayland. And there's not a lot of stuff going on relative to the United States of America. So this could be something for us to follow. This could be a big opportunity for you, for Australia and UK-based firms. The next news is from Evonik, and Evonik, is the leader in powder bed fusion materials still, with its PA12 materials and all sorts of other materials. But what it has been making inroads lately with the resins on the DLP, SLA markets, or the vat polymerization markets. And it's come out with 3 new resins: INFINAM RG 2000L. This is a photo SLA DLP resin for the eyewear industry specific. So what they're doing is they're making a resin that is ideally is very, very quick to process. Also could lead to clear parts, which could lead to transparent parts. The company hopes that people will use this to make what is a really emerging application, which is transparent kind of microfluidics components, which has a lot of potential as well. It's also helping the people make eyewear frames because it has a lot of UV degradation qualities in there, and it even kind of points to lenses, which of course lenses with SLA is quite problematic. But if you can do it, of course, it's a really nice technology. Um, what they've also done is they've made an RG 2000L or an RG 7100L. I'm sorry, that's a DLP resin, which is kind of an ABS mimic, kind of a very high gloss, very smooth resin, which is meant for like kind of like high throughput applications. It's machinable, so you can put threads in and stuff without breaking and stuff like that. So that's nice. And the most interesting one is by far the third one. It's Infinam TI 54L, and that is a PVC mimic resin. Right? Mimic, we say mimic because basically has nothing to do with PVC. Kind of, it just mimics the qualities that PVC has. They try to make these photopolymer resins in their final form, take on the qualities that one would see in a PVC, look a lot like PVC. For example, that's when I say ABS-like or PVC-like. They're trying to mimic that performance. That's why we use that terminology. But so this is really interesting because it's a PVC-like resin specifically for vinyl toys. You've maybe seen these things, these kind of vinyl high-end kind of collector's toys for adults. Maybe you've seen like robots or manga characters and all sorts of collectible things from all sorts of adult novels and cartoons and all this kind of stuff. Really high-end toys. This is it's not a big market when you compare it to automotive, but it's quite a big market actually. And what Evonik has done is made a resin specifically for this market, which I think is a really great way of listening to your customer and developing something. And I think it's also a wonderful way to enter the market. Evonik could go up against the big applications and try to really fight it out over small little advantages in chemistry or small advantages in price. But I think this kind of approach where you're developing a resin for a burgeoning market that really fits these guys' needs, that's a really way for me to capture market share and grow. And I think that's also what the DSM Somos, or no, Astralis Somos, I guess, used to do. They went to the guys from Formula One who were the biggest users and said, okay, what can we do for you? And then they ended up making specific resins for wind tunnel testing. Now, in the grand scheme of things, wind tunnel testing models and materials is not a big deal, but it sustained this whole industry for years because it was a really big thing compared to all the other stuff going on in 3D printing. So I think this is a fantastic market approach, which, by the way, Clariant and the former DSM parts that are now in Stratasys were doing before. This application-driven material development. I love this. I think that's the way forward. The next thing is a company we don't know a lot about it. It's called Vitro 3D. It's a spinout for the University of Colorado Boulder and has raised 1.3 million in seed funding. The only thing we do kind of know is, first off, the CEO, CTO, or SLA DLP researchers at Boulder. All right, it's a spinout of the university, and it's a volumetric 3D printing company. Now, we've heard a lot of exciting stuff about volumetric. The idea is that we print the whole part in one go, let's say, instead of just tracing out the layer and then tracing out the layer. Now, of course, volumetric seems amazing, right? It seems like it could be a lot faster. It seems like it's a hell of a revolution. Does it work on the floor? We don't know yet, right? So the company says it's a technology 100 times faster, and they're going to make the materials available in sealed cartridges for material handling. Now, of course, if we're looking at, and all the time they're talking about really like manufacturing. And if we're talking about a manufacturing type of scenario, these kind of sealed cartridges don't really, they're saying that sealed cartridge is an advantage for material handling. It is, but I think if you would do it at home, then it would totally be an advantage because you wouldn't have to mess around with bowls or resin. In an industrial setting, they have different solutions for that, and that's really not really what people are looking for. What they're looking for is to be able to do their own materials or to have really low cost material and to be able to make a lot of parts. Now, they're saying a lot of helpful things, like they want to make parts with minimal post-processing, they want to make parts faster. But I don't know, it's a bit confusing to me. Their go-to-market is we want to focus on two areas. One is dental aligners, like the molds for the dental aligners, and the other one is scaffolds for tissue engineering. And these to me are very, very different things. If we're talking about the dental aligner market, we're talking about a thermoforming insert that has to have a certain HCT, a certain heat deflection temperature to function, right? Because it's going to go in this thermoforming process, and it's got to be cheap. Minimal post-processing could help for a certain extent, but the problem usually is the problem that you have these attachment points to the bed, and this thermoforming thing isn't really an issue. And a lot of people use really low-cost resin for this. So even if the machine is really, really quick, it may not make the difference because if your resin is very expensive, then the part is going to be really cheap as well. So I'm not sure if they'll make the difference here. I'm not sure why they picked this. I mean, okay, it's a high volume application. People are making 250,000 of these things a day. I understand it. It seems really tempting, but I think I'm not entirely sure how a faster machine can really specifically make really a difference here. Because yes, you can make it faster. You can utilize that asset better, but again, if the resin is going to be much more expensive, it's going to cost $300 or $800 a liter, as opposed to $50 a liter. I'm not entirely sure that faster speed is really going to make a difference for you. So I'm not sure about that. The other thing, the scaffolds, for tissue engineering, that's a huge application, but it'll take a really long time for them to get revenue off of it. So it does seem like they want to do a 1-2 punch, like, yeah, we do volume and aligners, and then we sustain our business until the big bioprinting future of the whole world comes around. I'm not sure. I'm just a little bit skeptical about the aligners thing, whether that's the right application. We've seen a lot of new DLP, SLA companies trying to come into the market and not really be able to enter these hearing aid and the aligner market just because they're not able to withstand the economics there. So okay, we'll see. But it's interesting that we have a new startup, and it could be really cool technology. We'll see. It's very early days yet. Anyway, my name is Joris Peels. This is the 3dprint.com's 3D printing news unpeeled. Thank you so much for your time today, and enjoy your day.